So we're going to utilize our rules and do several examples of working through these problems to where we utilize the independence rules. So let's have a scenario, and let's just assume that we have some independent events. So S is the event of bowling a strike, O is the event having O positive blood, and B is the event wearing a blue shirt. And so the probability of bowling a strike is 0.27. The probability of having O positive blood is going to be 0.38. And then the probability of having wearing a blue shirt, is going to be 0.14. And so we can use that information and couple it with these rules to be able to answer all of the above. And so let's compute the probability of bowling a strike and having O positive blood. So that shouldn't be too difficult. So what we're going to do is we're going to say that we notice that we have the word and that means we're going to use this rule. So we're going to have, instead of P of A, we're going to have P of S, and instead of P of B, we're going to have P of O. And we just go up here, we know P of S is 0.27, and we know that P of O is going to be 0.38. And we just multiply those together. So we go into our calculator, and we're just going to say 0.27 times 0.38. And that's going to give us 1026. So one of two ways we can write it. We can write it as 0.1026, which is absolutely acceptable. If you wanted to convert it into a percentage, which sometimes a layman can understand, then that would be acceptable as well. Just keep it, though, as the decimal, so that way you don't make a decimal point error or something like that by accident. A second example. This time we want to find the probability of having O positive blood or wearing a blue shirt. And so notice what we're going to do is we're going to use this second rule to where we have the or. So we have P of A or B. And remember, we add them together, the probabilities, and then we subtract. So instead of A, this time we're having O positive blood, so that's P of O, plus the probability of wearing a blue shirt, which is P of B, minus P of O times P of B. And then we just substitute for O and B. Now we know P of O is 0.38. So it'll be 0.38 plus P of B, which is 0.14. And then we're going to subtract 0.38 times 0.14. And then what we're going to do is we're just going to go right into our calculator. So it's going to be 0.38 plus 0.14 minus 0.38 times 0.14. All right? And again, we're just substituting directly back into this formula right here, into our calculator. We're going to execute, and we get 4668. All right? So one of two ways, we could write this as 0.4668, which is absolutely fine. If we want to write it as 46.68%, that's fine too. Doesn't really matter. Next one. This is probably the easiest of all of them. What's the probability of not bowling a strike? All right. So whenever we see the word not, we're going to use the complement rule. So that's going to be probability of strike complement is 1 minus the probability of bowling a strike. And we know the probability of bowling a strike is 0.27. So 1 minus 0.27 is going to be 0.73. Okay, or 73%. Just depends on how you like to write it. For part D, now we're going to start coupling rules. So now we want to know what's the probability of not bowling a strike and also not having O positive blood. All right, so one of the things we're going to learn is that whenever we see a not, that's the first thing that we should do. All right, so we should compute all the complements first before we start taking care of like ands and ors and all those. All right, so first of all, we need the probability of not bowling a strike, which we actually just computed, 1 minus P of S, which is 1 minus 0.27, which is 0.73. All right, so that's good. We already know that. And then we want to know what's the probability of not having O positive blood. So we know the probability of having O positive blood is 0.38. So this is positive O complement, which is 1 minus 0.38. Technically, 1 minus P of O, if we're just going by the formulas, which is 1 minus 0.38, which is going to be 0.62. Now we go back up, and we notice one more key word. We notice and we know that and means to multiply. All right, so what we're going to do is we're just going to multiply those two answers together. All right, so we're going to get, so this is technically going to be probability of S complement times probability of O complement, which is going to be 0.73 times 0.62. And we'll just go to our calculator and compute that. So 0.73 times 0.62. And we get 4526. And of course, you can turn that into a percentage if you choose to. All right, so let's clear out some room so we can do the last two of these. And now we're trying to figure out what's the probability of not wearing, of not wearing our blue shirt or bowling a strike. All right, so now we have this or in there. So one sec while I delete all this stuff. That's close enough. So this is letter E. And we know the probability of not wearing a blue shirt. So probability of B complement is going to be 1 minus P of B, which is 1 minus 0.14, which is 0.86. We can compute that easily in our calculators. And the probability of bowling a strike. So notice it just says not wearing a blue shirt. Okay, we know bowling a strike is already going to be 0.27. So let's go ahead and throw this in the OR formula. So we're going to have probability of B complement plus probability of S minus the probability of B complement times P of S. So that's our formula right here. We're just substituting A and B with B complement and S. Is going to be equal to 0.86 plus 0.27 minus 0.86 times 0.27. Right? We're just going to throw that into our calculator. So we have our 0.86 plus 0.27 minus 0.86 times 0.27, and 8978. So that's our probability. And then finally, the last one says, what's the probability of bowling 3 strikes in a row? Now this is a little bit sneaky because it doesn't have any of the key words that we're accustomed to. So no ands, ors, or nots. Right? So 3 strikes in a row, we might think of that as strike, and strike, and strike. So we're just going to go through and we're just going to multiply P of S by itself 3 times. Right? So that's going to be probability of strike times probability of strike times probability of strike, because it's strike and strike and strike. That's what has to happen if you want to get 3 strikes in a row. So that's going to be 0.27 times 0.27 times 0.27, and that's going to be equal to, we just do 0.27 to the third if you want to. Okay, or you could just do 0.27 times 0.27 times 0.27. Hopefully this gives us the same answer. If not, mathematics as we know it has been redefined. And we can say it's 0.0196, okay? If we wanted to round it up, 0.02 or something like that. Okay, so this is going to be, sorry. So this is going to end up being, sorry, let's switch back, 0.020, or roughly 2%. All right, so hopefully that helps out with you being able to utilize these rules for probability. All right. So in the last video for this section, we're going to go through one more scenario. So what I would suggest is going through and trying to work through this scenario on your own, and then watching the video after you've completed those to see whether or not that you're able to do them, or if you made any errors, where you might have made those errors at.